Our first speaker is Professor Michael Batty from the Center of Advanced Spatial Analysis, University College London, UK. Okay. Professor Michael Batty is the Bartlett Professor of Planning at University College London, where he is the chair of the Center for Advanced Spatial Analysis. In fact, you started it, right? Okay. And so he has worked on computer models of cities and their visualization since the 1970s. I believe that most of you have read his book, okay? And he published books like Cities and Complexity. He won the Alonso Prize of Regional Science Association in 2011. And most recently, The New Science of Cities is the most recent book. Okay. So he has a blog that covers the science underpinning of technology of cities, and his posts and lectures on big data and smart cities. So you're welcome to visit the sites. Right? So his research group is working on simulating long-term structural change and dynamics in cities, as well as their visualization. So prior to his current position, he was Professor of City Planning and Dean at the University of Wales at Cardiff, and then Director of the National Center for Geographic Information and Analysis at the State University of New York at Buffalo. Okay, in addition to all these, he has all these prizes, achievements. So I'm not going to spell it all out, okay? So without further ado, I would like to invite Professor Batty. So we will be talking about defining and characterizing long-term urban change. Please welcome Professor Batty.
Just about to put the lights down, but somebody did it for me. Thank you for inviting me. I should probably say the first time I came to Hong Kong was 31 years ago. And indeed, for a couple of months, I was at the other university, south of here, the Hong Kong U. But indeed, the Croucher Foundation actually funded that trip, basically. So back in 1986, I spent about 6 weeks in the Center for Urban Studies down there. And in fact, in those days, we were working very much on land use transportation models, which I'm not really going to talk about at all in this particular context. What I'm really going to talk about, and this is to try and set the context to what's happening in cities, because this workshop is really all about what cities will be like in the next 100 years. Already this morning, the provost basically said something to the effect that more than half of the world's population now live in cities. It'll be up to about 75% in the year 2050. It'll probably be, and I'll demonstrate this in a moment, it'll probably be up to about 95% by the end of this century. So we're really talking about everybody really living in cities. So when everybody lives in cities, then clearly we need to characterize and define cities somewhat differently. Arguably, the very term city itself really depends on distinct entities. And if these entities are becoming less distinct, then to some extent, then really we need to kind of reevaluate. So this particular context is looking at the long term. Let me tell you what I'm going to talk about. I'm really going to talk about, to begin with, short and long-term futures urban change. And this is related to the fact that, in some senses, the smart cities movement is all about the short-term urban future. It's really about what happens within the city, if you like, the real-time city or the 24-hour city. On the other hand, most of our thinking about cities for the last 100 years has been in terms of long-term futures. When we prepare master plans, for example, they may be timeless in some sense, but the implication is that these plans would last for a number of years or a number of decades in that context. So a lot of our theory about urban science is related to the medium and long term, whereas a lot of our ideas about the smart city are really related to the 24-hour city, etc., where we're talking about change in a matter of minutes or hours, etc., or indeed days in that context. So there's a major issue in terms of dynamics. What's been happening, I think, is that as the smart cities movement has gained credence, etc., and as we've begun to embed sensors into the built environment, which produce data, big data, because they're continually streaming in this particular context, then we've begun to develop a new sense of what cities are all about in that sense. So in some senses, the optimistic view is that the short and the long term are coming together in some sense, that the short term is now being worked upon in contrast to the long term, which indeed was what we traditionally have always thought about in terms of cities. I'll then pull that together and talk a little bit about urban science and informatics. The point I'm making here is that urban science intrinsically is somewhat different from urban informatics, etc., and I'll define that in a way, because putting these two things together, the common medium between urban science and urban informatics is probably the digital context, the computational revolution in this particular way, not even the intellectual revolution in terms of being able to represent these ideas using mathematics and so on, but it's more to do with the notion of computability in some sense. That's where the heartland sort of comes. So you find people in urban science and urban informatics who come together because they have this common interest in computing and the digital kind of domain. And then, after this preamble, I'm going to talk about what are called singularities and the demographic transition. I want to actually show you, or at least give you a sense of what I think about the next 100 years in terms of world population in that sense, and introduce some of these, to some extent, outrageous ideas about event horizons and about the fact that at some point things may radically change in the next 100 years, and really to kind of foil that against urbanization in the 21st century. And then I want to move into cities themselves, future city size distributions. Is it correct that our cities are getting bigger? In fact, it looks as though it isn't correct, that the city size distribution, if anything, is flattening. We've got more little cities than big cities, and the proportion of big cities is pretty stable over the last 50 years or so. And it may well be that when everything is urbanized, etc., and to be a big city, you have to be a little city first in that context, that we may find, in fact, that the vast majority of cities are small in this particular context. That's true indeed at the moment, but it may be that more of our cities will be smaller. And then defining cities spatially, the $64,000 question in all of this is, how do we define cities? Normally, we draw boundaries around them. There is a kind of spatial context, but there are lots of ways of defining cities, etc. And then this leads to the notion about the shape of cities. Form follows function. And one of the points I'll be making, in fact, that it's very likely that during this century we'll see a break from this hallowed cliche of form follows function, in some senses, that form may no longer follow function. In this sense, there are lots of new functions, global functions being developed in cities, which don't have an immediate and obvious form, whereas 200 years ago, with the development of the internal combustion engine and so on, new transportation systems, etc., these had a very obvious form in terms of the city. Think about transportation of that kind, physical, against transportation of information in that context. What is the form in the city that pertains to information transmission on electronic media, etc.? So you begin to see the issue. And then I'll round off and talk a bit about the future for jobs. I think that some of the really big questions of the next 100 years will not really be about urban form particularly. They'll probably be about a future for jobs. They'll relate, in fact, to automation, and that brings us directly into the idea of the smart cities. And it also relates to productivity. It does appear, at least in the Western world, that productivity has been dropping for about 30 or 40 years in this particular context. That, again, it's a very highly arguable hypothesis, but it is related to the nature of technological change, technological disruptions and so on. And then really to round it off by what will cities look like in the 21st century. Now, we can't answer these questions. All we can do is actually probe the future in terms of what cities might look like. We have some sense of what this might be. Okay, now our view of cities is changing very rapidly as the digital world begins to permeate every aspect of the functioning and study, that they've been traditionally studied, at least for 100 years, in terms of how they change over years, and plans for their improvement have been structured accordingly. So this is really what I was saying about the notion that the timescales that we tend to have for planning tend to be longer rather than shorter. They're certainly not short at the level of what happens in the next 3 minutes, basically, or the next hour, etc., in this context. But a lot of smart cities technologies are beginning to look at that. I gave a talk at the Asia GIS conference over the weekend in Hong Kong U, and in that particular context, I talked about our big data set for similar to your MTR, tap-in, tap-out data in this particular context. Now, that really is a data set that tells us what's happening in the next couple of minutes, basically. So when we get disruption on trains, for example, we can actually measure it. We can measure the repercussions, etc. Now, the fact that we have this data, big data from the sensors in this particular context, really gives us the opportunity to think about very different questions in cities from those that we've actually looked at in the immediate past or the long past in that sense. So really the 24-hour real-time city and routine functions, etc., have become a central focus. And this has happened very rapidly. It's really happened in the last 5 or certainly 10 years. It's not that people did not think about the 24-hour city before. Of course they did. You go back to New York City and the police and fire service, etc., in a place like that, even as far back as the late 60s, early 70s, were concerned with actually what was happening in a routine context. But of course, they didn't have data, they didn't have automation to be able to do anything about it particularly. So it's this automation, which is loosely referred to as the smart city, that's making these things possible. And I guess for the first time, we're just beginning to embrace the real richness of cities and their problems. So we can think of this as an optimistic thing, that we're getting a sense of change in cities and richness in cities that we've never had before. So cycles of different length. Cities, of course, and there are many cycles, etc. So if I were giving you a talk about how we think about the mechanics of dynamics, basically, the dynamics of the next 100 years in terms of cities, then I'd probably talk about catastrophe theory, bifurcations, and so on. We don't have a very good map of these dynamics, apart from the fact that they ranged from very small, fine scale, temporally, and spatially, all the way to much bigger scales, etc. And, of course, in some senses, there are even bigger cycles dominating, such as technological cycles, etc. Indeed, cities emerged over the last 5,000 years, and as Louis Bettencourt will tell you tomorrow, I think, that they basically became crucibles for invention and innovation in that sense. So the agricultural revolution, 10,000 years or so ago, when people moved from a nomadic existence to settled agriculture in that sense, and then 2,000 years or so later, about 10,000 years or so later, the Industrial Revolution and the Post-Industrial Revolution. These are all cycles that are changing the nature of our cities in this context. Okay, so what are we going to do here? We're first going to examine the long-term future, showing that world population growth is more likely to be logistic than exponential. That's the demographic transition. And it really hasn't impacted us yet in some senses. You can still read about the Malthusian explosion of population, etc., but all the evidence suggests quite the contrary at the present time. Second, ought to demonstrate that the world will be completely urbanized by the end of the century. That throws onto the agenda what is a city. Then, of course, cities won't go away. We'll have small cities and big cities, so the city size distribution will remain probably similar to what is now. And the number of big cities may decline somewhat as a proportion of the total. And fourth, I want to just point you in the direction about city boundaries. One of the features about urban science is that we have a much better sense of trying to define what a city is and to actually measure its properties. There are many, many different definitions of cities. I tend to, I'm very much a believer that you define a city relevant to a particular purpose, and there are lots of different definitions in this particular context. And again, Louis tomorrow, I think, will talk a little bit about this. Hence size is relative to what's being measured and so on. So city boundaries are all important in that context. And that's just the spatial context. There are lots of aspatial and non-spatial features of cities that really pertain to their definition. And fifth, I want to show that cities will be dominated by changing functions in terms of jobs, general AI, for example, aging. All of these things may well be more important than the narrower context of smart cities per se, in that sense. Okay, so urban science and informatics. This is a long preamble, I know, but let me say a couple of things here, and just to repeat this question, that urban science is all about the properties and functions of cities with respect to identifiable arrays of objects, from people to buildings in cities. It's about how these objects, etc., scale, form, evolve, and change. It builds on physics and economics and probably sociology of cities in this context. It's very much concerned at the present time with networks of relationships. So generally speaking, were we to agree on a definition of urban science, these things would probably be part of it, right? Of course, my point is going to be that narrow definitions or tight definitions are quite problematic in the world that we inhabit. Urban informatics is somewhat different. It may use urban science in some context, and it certainly is central in terms of computation in this context. But urban informatics is about embedding information infrastructure into cities and exploring how people change their functions and behavior. It's about big data generated in real time, and it tends to operate at finer spatial temporal scales than urban science. And I guess Charlie Catlett tomorrow will be much more talking about, this is on the assumption that I'm guessing on the basis of what Charlie has been doing in Argonne for a number of years. And in the middle, I think, between Lewis and Charlie, Gerhard will talk about big data and urban design, basically. So in some sense, this is a great mix of things. And the idea that we can bolt it all together and produce a neat, tidy formulation is quite problematic in that sense. Okay, so let me begin by talking about the demographic transition. Now, this is a diagram which shows you world population growth from the early Stone Age to the present day. And you can see that something rather strange happened after something like 70,000 years or so, around about the 2,000 or so years ago in that sense. And you can see the beginning of a takeoff in this particular context. And you would be forgiven for thinking that that this particular curve could not continue, because if it continues, it will go on towards what is effectively infinity, etc. So this is the challenge to understand population growth in this context. If I change the scale, let's look at the last 10,000 years or the last 12,000 years. Minus 10,000 is more or less the emergence of agriculture, and then round about 4,000 or so BC, or 3,000 or so BC, you got the beginnings of cities in this particular context, and you can see the takeoff in that context. Let me move it back a bit more to the last 2,000 years from what we normally say is 0 AD through to present day, and you can see this curve. We've got a bit more detail on it in this particular context. Now, to some extent, were we to extrapolate this and fit something to it, then indeed we would find that it would be shooting off towards infinity. And this is referred to as the singularity. Now, the reason why it's called the singularity is, I'll tell you this in a moment. It's to do with the nature of the curve that we can actually fit to this. Back in 1960, it looked very much as though the old Malthusian notion that population would increase at an order of magnitude greater than the resources to sustain it was right. I remember as a high school student in the UK doing an economics class at what was A-level in those days, and they talked about the population of the world was 3 billion. And talking about it would double, etc. The notion was almost beyond comprehension back then for a schoolboy to actually think of population doubling in that sense. Of course, our experience was of living in reasonably dense cities, etc. at this particular time. And of course, one didn't realize how this would play out globally in that sense. Now, there were many attempts back in the 1960s to look at future population growth in this sense. But one of the most dramatic was made by a cyberneticist at the University of Illinois, von Förster and his colleagues in 1960, when they fitted what was essentially a hyperbolic curve to past population growth, producing an excellent fit. They actually said that the very best curve that you could fit to this, in fact, was a hyperbolic curve. Now, a hyperbolic curve is like a power law, basically. At certain ends of it, it either goes to zero in the limit or it goes to infinity in this particular context. Normally, we show it the other way around, etc. But essentially, what they said was that if the hyperbolic curve is indeed a good fit, and they were making the point, they were not saying that populations would increase to infinity. They said the hyperbolic curve, when fitted, would give you an infinite projection. But from this, they were able to predict the year when the world's population would reach infinity. And they established this as November the 13th, 2026, basically. Here is their paper. They called this Doomsday, Friday the 13th of November, AD 2026. This is an article in Science, basically. And essentially they said that that they could actually predict the point at which the population would become infinite. Now, it's quite important to note that the context in which they were working was a context in which the biggest growth rates in world population had occurred in the 1960s, basically. Since then, they've plummeted the world population growth rates, in a sense. But back then, when von Förster and his colleagues were actually thinking about this, it was quite clear that populations were growing at this super exponential rate in some senses. Now, if, for example, population heads off to infinity, then this is referred to as the singularity. Now, the singularity is essentially a point in the curve where really the curve is not defined, basically. It's very easy, and I'll show you this in a moment, very easy to figure out. You don't need you only need high school algebra to actually figure this out. The singularity is when you get something divided by zero, basically, in a sense, in this context. And that's what the hyperbolic curve would show you instead. Now, of course, it's much bigger than this. The singularity, there's a whole school of thought about what's going to happen in the next 20, 30, 40 years, much of it associated with Ray Kurzweil, who talks really about the technological singularity. There are some really quite outrageous phrases in Kurzweil's sort of writings. He's written many books about this, and he's really talking about the fact that one of the singularities which will occur in the next 30 years is the notion that we'll all become immortal, basically, in that sense. We'll live forever. And he says the rate of change is so great in modern medicine in terms of embedding information technologies into ourselves, which is probably the next wave. After the smart cities revolution, we're probably going to have the smart human revolution, where technologies like this get embedded into us rather than into buildings in this particular context, and that's beginning to happen. Kurzweil, etc., there's a lot of stuff on this. I shouldn't probably tell you this, but my son, for a whole range of reasons, found himself working in Marina del Rey in Los Angeles for a kind of hippie startup, basically. It was, these guys were trying to invent artificial intelligence from the ground up, you know. They had heard of Turing and so on, but nevertheless they were fairly outrageous sort of people. But at the same time, they also believed in the singularity, and they'd put plans in place to get themselves frozen, basically, you know, as they reached the end of life, get themselves frozen, waiting for the time when they could be unfrozen, basically. And there are lots of, the United States, there are lots of big factories given over to this. I worked in Phoenix for a bit, and lots of factories given over to the fact that if you've got the money, basically, you can have yourself frozen. God only knows what it'd be like when you get unfrozen, basically, assuming this singularity goes. Anyway, there's a lot on this, and I'm not going to go into this because we really want to bring it back to cities, etc. Okay, now this is the equation that von Förster and his colleagues used. It's very simple. It's a very simple equation. You can see the idea of the singularity directly, that the population of t, n brackets t, is equal to a constant divided by td, which is the date of doomsday, minus time, basically. So you can see that as t gets closer to doomsday, we don't know what doomsday is, but we can get it by fitting the data. As t gets closer to td, in a sense, then this begins to shrink, this bottom line. And when t is equal to doomsday, then the bottom line of the equation is equal to 0, and the population is infinite. It's a very simple kind of curve, basically, in that sense. It's a kind of simple power law, in a sense. I mean, power laws pervade the whole of urban science, basically. I don't really want to get into that because I'm sure that's going to come up in future lectures in this symposium. But generally speaking, this is a very simple kind of relationship. Of course, it assumes that the hyperbolic curve is appropriate, and indeed the hyperbolic curve was appropriate back in 1960. Von Forster, in his science article, really demonstrated this. So this is all. And the way we actually work out what doomsday is, we regress 1 over population at different points in time against td minus t. We don't know what td is, but when we do the regression, we don't need to know what it is because it will actually become a feature from the equation that we can actually predict, basically. Now, we've done this for world population from data from about 1400 to 2000, and also for the top 50 cities, which I have in my little rank-size database that I've used over the years, basically. And this is what you actually get. So, for example, we have 1 over the world population on the left-hand axis. Okay, so that's 1 over the population, and we can get that. We know what world population has been over many hundreds of years. In a sense, very detailed knowledge of that now in the present day, year by year. UN produced that data. We've got time. We know when the times of these things are produced. And we get what is effectively, if the model is any good, a straight line. And so you can actually see that 1 over n is getting smaller and smaller and smaller as t increases. And of course, when 1 over n is equal to 0 in this particular context, which is effectively saying that 1 over n, 1 over infinity, the world's population is equal to 0, then what we can do is actually project that line to see where it actually cuts the axis. So this is what Von Forster did. The red line, you can just about make out the red line, I think, which is actually fitting the world population over this period of about 600 years to the data, and we get 2026. If we do it for cities data, the top 50 cities, then, and this is interesting because we are interested in how the top 50 cities are performing, or the top cities are performing relative to total growth in population, then we get a slightly different rate. And if you open Kurzweil's books, etc., there are countless predictions of doomsday, or the singularity, I should say, at years from 2026 onwards. Now, one has to be, to some extent, cynical about this, because essentially what's been happening is that if we look at more recent rates of population growth and world population, we're seeing that doomsday is being pushed back all the time, basically. And I'll show you a graph of this in a moment. That, in other words, as we get closer and closer to doomsday, doomsday is being pushed back because basically the growth rates of world population are dropping. So the next slide actually shows you this is the singularity. That's probably what's beginning to happen at the present time. Now, how can we actually demonstrate that? Okay, so this is data taken from a website called GeoHive, which basically extracted a good deal of UN population division data in this particular context. So that's really from the last 2,000 years, and you can see the curve. This is UN predictions, basically, and it looks as though it's bending over in this particular context. So the tipping point is barely detectable if we just look at the black dots, which is existing population, but the UN projections suggest indeed that the growth rates are dropping. We do indeed have the growth rates. So, for example, this is the same. If you look at the left-hand side here, then this is population growth between 1950 and 2100, that black line on the left. And this is the actual growth rate of world population. Go back to 1960, where I've drawn the straight line north, and you can see that at that point, this is the von Forster. This is the reason why I was so convinced, or it was so convincing an argument, was at that point, the growth rate had reached really a maximum. If I were to project this line backwards with more data, the growth rates, in fact, of world population would be less. So, in other words, you've got a kind of a sort of a normally produced curve where the maximum growth rate is in 1960. Hence the reason why he was confident about making the speculations he did in that sense. So you can see this is really the most important issue. This is the growth rate plummeting, right, over the next 100 years. And it's been plummeting since about 1960, 1970 in this particular context. And that's the projection. Now, what we have on the right-hand side is quite interesting because basically on the right-hand side, we've actually got the proportion of population as produced by the UN, 1 over population, and we've plotted a curve of that 1 over population, and we have very detailed data from the UN every year, basically. So we're plotting 1 over population every year, okay, running forward in time, and that actually gives us, because we've got a resolution of a year, basically that gives us almost a continuous curve. And if you think of putting a tangent to that curve and projecting it, then to some extent, this is sort of saying that the regression actually associates with the particular point on the curve, or the straight line associates with a particular point on the curve, and you can project forward. And you can see effectively, as we go down this curve, then doomsday is being postponed. And of course, eventually, if that curve were to flatten out, basically, on the right, then basically doomsday would be postponed forever. And of course, in actual fact, we're never going to get doomsday in this sense. Von Forster himself, von Forster, thanks, he basically did not suggest to us all that doomsday was a reality in some sense. He was actually using it as a thought experiment to think about what the implications of all this were. Okay, now the other interesting feature, I think, is that if we push our time scales a little bit longer, if we forget, for example, what the horizontal time scale is, then, and if we think of maybe on the horizontal time scale, this is going from minus 10,000 BC to 10,000 AD, basically. So this is 20,000 years or so in this particular context. And we were to go back to the graph I showed at the beginning, where you had this almost cliff-like sort of increase in population over 10,000 years or over 70,000 years, then we may well get something like this. That, in other words, cities really, which really didn't get going in any sense until the Industrial Revolution, something that's an arguable point. I mean, Jane Jacobs and so on have talked about this in her Wealth of Cities and so on. But nevertheless, if you think of cities as being artifacts that really only came onto the agenda in terms of modern technologies round about the 17th and 18th centuries in this context, then a good deal of what's happening to actually put us all into cities, etc., is happening over a 200, 300-year period. So something like 1800 to 2100 in this particular 300 years, basically, you have to compare that to 10,000 years and 70,000 years in this particular context. So to some extent, this is a sort of tipping point where we are at the present time, and this is our era, and this is the previous area when there were no cities, and when there were cities. In fact, the various people in Wired magazine wrote an article, Dave Rowan, who was the editor, where he talked about City 1 and City 2 in some sense, in terms of like Web 1, Web 2, etc. But to some extent, it's more accurate to think of no city in the past and all cities in the future in this particular context. Okay, urbanization. Conscious of time here, let me try and speed up a bit. Urbanization in this particular context really relates to persons living in cities, etc. So here's our singularity again. What we've got on this graph is population in billions on the left-hand axis, and the top 50 cities in millions on the right-hand axis. And we can see the red curve is the one for the top 50 cities. So the red curve is accelerating faster or has done since 1500, basically, than world population. So this looks as though the growth of big cities is happening faster than the growth of world population. To some extent, this is quite a controversial thing. If we take the ratio of those two curves, basically, if we actually take, let's see, what is this? If we take the red curve divided by the black curve, I think, in that context, then this is what we get. For really about 1700 years, we had a relatively stable proportion of cities, etc. And then suddenly, in the Industrial Revolution, it began to take off in terms of big cities relative to world population. Now, related to this, of course, is this big question about urbanization. I just want to throw this onto the agenda. This actually is the proportion of city to world population over the last 100 or so years, basically, and the projection up to about 100 years in the future, a bit longer, in fact, from 1940 to 2140. Now, this is taken from UN data. So that's the proportion of city to world population. You could see back in 1950, say, it was something like 30%. Extend the 50% line, or the 0.5 line across, and project down, and you find this magical year of, is it 2003 or 2008, when 50% of the world population became urbanized in this context. We can extend it a little bit further, etc. So it's probably now about 60%, something of that sort. The UN have actually extrapolated it in this particular context through to about 2050, and we're talking here about roughly, a little bit less, I think, than 75% in 2050. And if we were to extrapolate that in the future, it's a slight curve. It's not completely linear, basically. Extrapolate that, then essentially by the year 2090, then everybody in the world is going to be urbanized in some sense. Now, this throws onto the agenda the difference between urbanization on the one hand and cities on the other. It's a very uncomfortable relationship because it is used interchangeably. An urban system is often thought of as a city system, etc. But nevertheless, urbanization is not necessarily the same as living in cities in this particular context, a different feature in this context. So we really need to be cautious of this as well. And urban science, I think, can actually inform us quite a lot about these sorts of issues. So this is really saying that once we get the world, once we get a relatively stable world population, and of course I should say that, let me just go back to the singularity. Okay. I should say that there's no guarantee that this curve is going to turn into, from a hyperbolic into a logistic. It looks as though it is at the moment, quite dramatically because the growth rates are plummeting. But you know, the next 100 years or so, that curve could be all over the place. It could actually decline, world population could decline. Anything could happen in the future in this particular context. It's more likely to stabilize, I think, in this context. The UN rate is about 10.5 billion by the end of this particular century, which will be stable. These are continually being revised, etc. So it's important to note that it isn't necessarily a logistic, but it certainly isn't a hyperbolic in this context. Okay, let me race forward back to where I was. Okay, future city size distributions. Now, this is, we've taken the top cities from our own data. We've taken from one of our data sets, and we've looked at the top 10 cities from 1950 to 2015. That's the first line. And if you look at the proportion of population in those top 10 cities, it declines from about 13% to about 12% in this data set. And then the top 50, you get less decline. It's around about the same, 0.356, 0.355. Not much change in this particular context. And when we get down to the top 100, in fact, in some senses, the bigger top 100 cities are growing faster than world population. So this is essentially what we're doing. So to some extent, we have a kind of dynamics in terms of big cities and little cities that we need to unpack in terms of actually what's happening in this particular context. Of course, all of this depends on the definition of cities and the measurement, and I'm going to come on to that in a moment. So these are the rank size rules that, for those who don't know about rank size, what we do is we take the population of the city, or the population of the cities, I should say, because these curves are all cities, etc., and we rank them from the biggest city to the smallest city, and then we draw the curve of population versus rank. We take the logs to get rid of the power in this particular context, and you can sort of see that to some extent it's not a particularly super convincing explanation, but it gives an indication that things are flattening a little bit, that in some senses from this particular data set there do appear to be a smaller number of big cities, as the data shows, than of small cities, etc. We've also looked at it with a new data set, and I'll come on to that. The Joint Research Centre have a data set that they've produced from a whole range of remotely sensed data and population data for cities over the whole world. It's called the GHSP, which is the General... I can't remember it now, but I did remember it the other day. It's basically the data set that they released recently, and it's data which is actually grid square, so you can plot it, etc. But what we can do is they've also defined what they consider to be the top 13,000 cities in the world, basically, and they've used various definitions of this, such as density, commuting, and so on, as well as physical proximity, and therefore we've plotted the rank size curves. And the rank size curves, this is exactly the same as previously, the top 100 cities, the top 50, the top 10. In the top 10 cities, they're more or less the proportions are the same. The reason why these proportions don't bear any resemblance to the previous ones is largely because we have a different number of cities in this set for these two data sets. And that the top 50 and the top 100 look as though those cities are increasing in size relative to total world population. Okay, now it's very clear that as we define different hinterlands around cities, their size and many other quantities changes. One of the great controversies which we've been embroiled in to some extent with Louis Betancourt and the Santa Fe group is that what they've been arguing is that as cities get bigger, they get wealthier. Okay, this is the famous Alfred Marshall hypothesis from the late 19th century about urban agglomeration economies. And basically, they've demonstrated in their PNAS article back in 2007 that from MSA data, Metropolitan Statistical Area data in the United States, they do in fact reveal that incomes get, or wealth, if you like, or income or whatever, increases more than proportionately with city size. Of course, it really depends on how you actually define cities. We've not found that in the UK. The UK seems to be a special case. Arguably, there's one big city in Britain, which is London, and everything else is kind of hooked on the end of it. That's one theory. The other notion is that London is just so different from the rest. Another one. But the biggest issue is that how do we actually define these cities, etc.? And as we define them differently, we get different measures. So defining cities spatially is really very important in terms of saying something about them. If you're talking about a happy city or a city with quality of life, you really need to know what you're talking about, because I know lots of cities where the quality of life is superb. Quality of life is fantastic if you live in Kensington in London, right? But I mean, if you kind of extend it to Hackney, etc., it can be pretty awful. I mean, in some senses, what we're saying here, etc., is how we define the city will make a difference, etc., in this particular context. Okay, so here are some pictures of how city form has changed. And this is really moving on to the notion that what do cities look like in terms of their form. And this is a very important part of urban science. For example, me and Paul Longley wrote our book Fractal Cities about 25 years ago, and that was all about how we looked at the shape of cities, about urban morphology. Now, these are pictures from 5,000 years ago, basically, Sumerian clay tablets, a little map of Babylon, a couple of tablets there, etc., showing you that you have these well-defined fortress-like towns, basically, for obvious reasons in this particular context. Here are some pictures of how he thinks it. There are different scales, but of course scale has changed massively. We're talking about populations of very small numbers 2,000 years or so ago relative to today. So here is Carcassonne in southern France, and this is one of the Italian Renaissance towns, basically. It was built, I think it's in northern Italy somewhere. And there's a picture of London, all at different scales, basically. And then that's a picture of Europe, basically, taken from a grid square. It's not Nightlights data, but it is gridded data from the European Commission, from Eurostat. So essentially, what we're talking about is we're asking the question, how would the shape of cities change during the 21st century, basically? They're going to be much more like the bottom picture in terms of Europe in this particular context, much less in this particular context, clearly here, in that sense. But the next thing I'll show you is that the JRC data set that we've been using here, it's compiled from a lot of remote imagery. It's ground truth with population data and buildings data and so on. So it's a very big project. JRC, by the way, the Joint Research Centre, never quite understood it, but basically one particular Joint Research Centre at Ispra in Italy, it's financed by the EU, and it has lots of things that relate to environment and population and so on. In fact, very interesting, from this new data set they've got, then the biggest constellation in the set, so this is a new definition of cities, the biggest constellation in the set is Hong Kong Guangzhou, the Pearl River Delta, which is something like 47 million. Tokyo, I think, is about 38 million in this particular data set. Now, one of my colleagues, Duncan Smith at CASA, has produced a very nice viewer to explore this data. This data is downloadable in this particular context, and these are some of the web links, etc. I'll show you the picture of this area here, and then bring it up. So this is his viewer. It's on the web. Luminosity3d.org is the website. Sorry, you can't actually see that down there. I'll click on that in a moment. And this is Hong Kong Guangzhou in this particular context. So let me load it up, basically. So this is his viewer, etc. They're quite neat. And it's interesting, if you zoom into, you can really begin to see, when we zoom into Western Europe, some of the real conundrums about defining what cities are. I mean, in some senses, it'll sharpen up in a moment, you can actually see the kind of issues involved. It's bad enough in Britain to think about defining cities. It looks easier in Britain, etc., although this sort of stuff here, which is, Nottingham all the way up to South Yorkshire, Birmingham, and then the northwest, all of this stuff merges into each other. London itself, you can see fairly typically. But once you get into the Netherlands, right, and Belgium, it's really very problematic here and into the Ruhr in this particular context. The Ruhr particularly is Dortmund a city, is Dusseldorf a city, and so on. To some extent, to measure these hypotheses about if big cities get richer as they get bigger, and all sorts of other things change in that sense, we really needed a good definition of cities in this particular context. Okay, you can, if you get onto Duncan's site, Luminosity, and he has another site somewhere called City Geographics, I think. You just go back. citygeographics.org, basically. You get there, in that sense, from his blog, basically. So it's quite interesting stuff. I mean, this is in the public domain, quite recent, etc. And again, it gives a great dialogue in terms of thinking about how we can talk about these issues in terms of cities. Okay, now we've done a lot of work. Now, some people here have seen this before, because I've given talks on this. We've done a lot of work on thinking about how we partition cities, etc., and how we define different definitions of cities. This is the street network, and how we kind of define clusters as we move down at different levels. And as you see, this is Britain, and we're moving down to regions in this, the southeast, and the rest is quite distinct in that sense. At some point, we get down in terms of our clusters to cities in this particular context. At that point, we're actually below the threshold of cities because North London is disconnected from South London. That's 100 metres. The bridges are about over 100 metres on the Thames, basically, so we have disconnection. So this is done using a clustering algorithm. This is from the Careen data set, which is actually, we think, quite a good data set for defining physical boundaries around cities. Of course, the big issue is, in all of this, is whether where we draw the line, does a city have to be physically attached to all its bits, basically, to be called a city and so on. And this is density in this particular context. So what we've been doing is we've been really looking at two things. We've been looking at density, we've been looking at percolation clusters as a kind of physical thing. We're looking at density, and we sort of more or less come to the conclusion that 14 persons per hectare is roughly the area we would consider a city to be above that, basically. That's the level of population density where we can separate Liverpool from Manchester, basically. And arguably, to study Liverpool and Manchester, you'd probably need to put the two together, basically. So already, in terms of that debate, it's quite problematic, etc. But nevertheless, if you come from Liverpool or if you come from Manchester, then they are daggers drawn, the two famous football teams in each, in that sense. And identification with the city is all important in this sense. So, in other words, there is meaning to actually doing this in this particular context. Okay, shape of cities, form follows function. Okay, now all of this poses enormous conundrums to how we define cities. What I'm illustrating, I think, this morning is that these are lots of, slightly disconnected bits and pieces that are relevant to thinking about this long-term urban future in that sense. The big question is, will our cities of the future be largely monocentric in function with more polycentres, or will their central functions simply melt away into the net? And that's something I think we really do need to actually consider in this particular context. Increasingly, we're beginning to see that what we see in cities is a kind of inert building infrastructure from the past, and what goes on in this particular context is problematic. Now, Louis Sullivan, the great Chicago architect, coined the phrase, form ever follows function. That was his precise thing in his little essay in 1901 or whenever it was. And I wonder whether this is about to be replaced with the cliche, form never follows function, etc. So we could well be into this game or this debate. Of course, form will always follow function in certain contexts, etc., so it's relative, etc. But we are into this notion about to what extent can urban form, which we have used extensively to think about future cities and optimal cities, still be a credible issue in terms of the urban future. Okay, in fact, I can't show you this, but going back to the smart city thing, can't show you because it doesn't actually display, although we've got a little picture here. This is a movie which shows the changing polycentric nature of central and inner London over a 24-hour period. Polycentricity and monocentricity in terms of cities tends to be thought of in terms of centres, edge cities, things of that sort, how cities merge into each other. But it's an obvious sort of change in terms of where people are originating to and travelling to, etc. So when we plot this movie, what we actually see is origins and destinations, tap in and tap out, basically, and we see this bubbling cauldron of different kinds of dominance, basically, of these centres, dependent on what time of day it is. So we have a kind of 24-hour version of polycentricity. How that maps onto the nature of polycentricity in terms of development, etc., in a complex entity like London, for example, is the $64,000 question. It seems to me that one of the great research areas could well be how we begin to think about urban form in the long term as well as the short term, etc. And that really is joining the smart city type stuff to the ideas about urban science. Now, I can't show you that, and I just want to, before I actually finish, just want to make a couple of points about some of these other big questions that I don't address here particularly, which really relate to automation and smart cities. It could be argued that the smart city, the wave of smart cities, is really just another wave of automation in modern society. And I made the point that this wave will pass, it'll become less significant, etc., and the automation of ourselves might be the next frontier, etc., in some senses. The other feature, I think, is that productivity in this particular context, and this really relates to the nature of the economy in some sense. The technological singularity is almost upon us, etc. There's also an economic singularity that, of course, it's too early to say that the economy has changed dramatically, the world economy, but it does look as though it's changing dramatically at the present time. And this is a kind of economic singularity. And if you add all of the speculation about where the jobs going to come from and so on to this, then there could really be some quite major change over the next 20, 30 years in terms of what goes on in cities. Because at the end of the day, these big issues will ultimately impact themselves in where we live, which is in terms of cities. And it seems to me that when population growth ends, which it probably will, it looks as though world population growth ends, then migration will become the name of the game. And I think we can already see this to some extent. And you can really begin to think about this in terms of the sort of stuff you see in Duncan Smith's database, that in terms of the growth of populations, etc., then a lot of the growth of populations in the big sprawling entities, etc., such as in this region here, are due largely to a migration, etc. Another feature, I think, of this is that, and I'm sure people will talk about autonomous vehicles at some point in this meeting, but a lot of this kind of autonomy really depends on general artificial intelligence. My personal view is it's quite problematic, actually. It's quite, I mean, things like deep learning and so on, I mean, just skin deep as far as I can see. I mean, but nevertheless, these are important issues that will tax us in terms of thinking about how we actually develop new functions in cities, etc. Okay, now I'll finish really with a few points about what cities might look like in 2100. Polynucleated masses with ordered cores, but many more cores than in the past. That seems to be what's actually happening, etc. It's quite consistent with the idea that we're all living in cities of different sizes. Cities will cross national boundaries and the continued rise of the city-state, I suppose. That says massive changes in the job market, which are going to have important impacts on housing and service delivery. Something I haven't talked about at all in this particular context, but has an enormous impact in terms of automation and services, etc. Real-time data acquisition and modelling in Apache way, as we grapple with just how hard this science is to do. But real-time data acquisition could well extend into data sets that are useful both in the short term and the long term, as long as the sensors remain switched on, basically. Because most of this data, this big data, is not being collected by people who are collecting it for us, basically, etc. It's being collected so you can look at the payment system on the metro and so on. Then they don't have a vested interest in keeping the system stable, particularly in that sense. And I guess that one of the things that's going to come up is the fact that although we have big data from real-time sensors, the sensors will begin to change and we'll begin to lose the ability to think about the very long term in this context. And so really all of this, I suppose, it reflects new ideas about urban dynamics, etc., and things like discontinuities, phase transitions, catastrophes that I've not really talked about, and network repercussions, etc., all need to be built into this picture of the next 100 years, and I suppose that the list is endless. Okay, I'm going to stop at that point and thank yourselves in the Institute for Future Cities in the Chinese University of Hong Kong, and also, of course, the Croucher Foundation, who have made this possible. Thank you.
Okay, thank you very much. I would like to thank Professor Batty for taking us through the projection into our urban futures Okay, so it looks like that we have a lot of things to do, right, in the future. So now I would like to open the floor for questions and the discussions. Okay, are there any questions from the floor? Yes?
Thank you, Professor Batty. I'm Elsie from the CUHK, and I'm really inspired by the projection of population. And my question is actually about the future of city. So with the change of the jobs in the future, do you think that people really need to live in the city, or maybe they would prefer living in the rural area, and they could still get their jobs done and they do not need to travel to the city? So could this be a possibility of the future cities? Thank you.
Yeah, I mean, this is an old question, I think, that goes back a long way. That Alvin Toffler, in his book Future Shock, I think, in 1970, wrote about the electronic cottage, basically, where we were all cloistered in a rural paradise and linked in. E.M. Forster, in his book The Machine Stops, in 1909, talked about a world which was completely dominated by information technology, where nobody really talked to anybody else in terms of physical face-to-face contact, etc. And people have speculated very much on this question about the extent to which people will live and work at home. And in some senses, even these predictions that the city would disappear or melt away in this sense because of this have not really been borne out. George Gilder, there's a wonderful phrase from George Gilder, Carlo quotes it in his book on Tomorrow's City. George Gilder said that in 1990 that cities were a remnant from the industrial age, basically. Well, I think he's having to revise his view, basically, since then. And that's only 20 years ago. So really what we're saying is that we probably don't have a very clear view about the answer to your question. I think what we might be able to say is that we might be able to say something about the fact that people might work from home but also work from work. In other words, if I look at my own behavior, it's probably pretty unhealthy, but as soon as I get up in the morning, I log on to email. In the old days, as soon as I got up in the morning, I'd sort of work a bit more on the paper. But that might be my position in terms of life, basically. I don't know. But what I'm saying is that we're dominated by communication at that level. So we're working all the time, or we're interacting all the time. May not be work, and it's not necessarily place related. All of that is new to some extent, and it's a little bit like what you said. My view would be that we're using these information technologies to complement rather than to substitute, in that sense. Francis Kerncroft talked about the death of distance in this sense. It doesn't look as though distance is dying in any sense at the present time. So this is a very complicated question, I think, and one that needs to preoccupy us. I mean, because, in terms of your question, we could say that the next 100 years are when that question will be answered in some sense. And it may be answered very differently with very different sorts of communities.
Thank you for your talk. And the population of the world, the plot you are looking at is by looking at the world population as a whole. But if we look at the population in different countries, the features might be quite different. Like the population in most of the developed countries might have already reached the tip point, but for some countries, like the developing countries, especially some the rising developing countries in Africa, most of the contribution of the increased population might come from these countries. So do you think that if we can analyze the data in the developed countries to see how their population increase and apply to the developing countries, then we may get a better prediction of the world population? Thanks.
I don't think there's any doubt that if we were to disaggregate the data, we'd get a richer picture of what was actually happening, and we would see these differences. There's no question. Of course, we would see these differences if we looked at the last 50 years too. We'd see how some countries have passed through this demographic transition. This is the transition of moving from basically large families to small families in this particular context, but it's also very much affected by modern medicine. It's affected to some extent by attitudes and so on. And it varies enormously culturally in different parts of the world. You're absolutely right. Were we to do this for Africa, we may come to a somewhat different conclusion about explosive growth in the 21st century. My view would be, and I mean, I'm not an expert on this, but my view would be that we probably wouldn't. We'd probably find that these trends were also happening in many African nations, etc. I'm not saying that there are confounding factors here about the fact that we're all living longer, and that's true of wherever we are in the world through a whole set of changes that are going on. So to some extent, it's a complicated picture as soon as we begin to disaggregate it. So I think you can only take what I said as being a speculation. I mean, that's what von Forster said too. It's a speculation. It's not the truth. It's a way of thinking about the future. And it doesn't say that there aren't other ways of thinking about it. Indeed, I think that one of the key things about thinking about the urban future is there really are a massive number of ways of thinking about what will happen in the next 100 years when it comes to cities in that context.
Thanks, Professor Michael Batty. It's very inspiring lectures. And my name is Chao Ren from the Chinese U. Actually, in China, this year, the central government, they changed the policy. They said in future in China, the cities cluster will be the target. And that means not the big city, actually the big region, this kind of idea. So what is your opinion about this? And also how to define the boundary and also this kind of database apply for the urban development, especially in the China, this kind of developing countries? Thank you.
Okay, I mean, the question of defining boundaries is an age-old one, I think, for geographers, that my view, I think, is that, and this is not anything specific to me, a lot of people hold it, is that we need to define the boundaries of cities with something in mind, basically. So in other words, if we want to define the boundary of a city so that we measure how much commuting there is into it, or how much income is flowing in, what's flowing in and flowing out, etc., that might give us a very different picture of what the boundary is were we to talk about, say, environmental influence. I saw something recently where the boundary of cities was being defined by massive watersheds, basically. This was in the United States, that really the city itself has to be thought of within this much bigger context of natural resources supplying it, etc. So I think it's horses for courses. It's basically what purpose you have in mind in that sense. And an administrative purpose may be very different from a technical purpose. I think the critical issue is that it depends on what we're going to do with the data or the measurement that we actually make. And in some senses, the implication is that if bigger cities are more wealthy, all other things being equal, of course, if bigger cities are more wealthy, then do we develop policy which makes bigger cities, basically, in that sense? And that is much more controversial, I think, when we make that second step. We might demonstrate quite conclusively for certain definitions of cities they get richer. But to then go on and say we need to make them bigger, because that's where we build in. Well, one of the things about the richness of cities is that as cities get bigger, they may get richer, but they also get poorer at the same time. So the poverty, which increases intensely as cities get bigger in the United States, is wiped out by the more than proportionate increase in wealth, if you see what I mean. So what you're finding is that although a city on average, or the cities on average may be richer as they get bigger, it is only an average. When you actually look at the distribution within the city itself, you're finding that that can actually be much more extreme, much more unequal. So inequality comes in here, etc. So it really depends on what you're defining the boundary for. Now, I don't want to give the impression that that we're able to solve these problems anyway. I think they're quite problematic, this whole boundary question. I think we have some better sense of it now, of what the issues are, etc. But we're a long way away from producing any definitive. We may never be able to produce any definitive kind of answers to what the best boundary would be. But we have to look at it relatively.
And may I ask a second question?
Mm-hmm.
And I think today's topic talk about the smart city, the database, informatics, and almost a lot of teams and also the very ambitious or very passionate about this kind of database development. So what is the future for this kind of international collaboration for different kind of database? So people can really make the accessibility and also standardize and also for the implementation, this kind of database. So what is your opinion about this?
Well, I think there have been some quite interesting developments in the last 20 years just in the context of, say, world population databases, like this Joint Research Centre thing I mentioned, and then there was a group at Santa Barbara, again, it's part of the UN Statistics Division, I think, the work got picked up. So there's a variety of different global data sets, if you like, that increasingly are beginning to be populated by things at a finer scale. So I think that's an important issue. And, of course, if one's talking about a global data set, it's almost inevitable that there has got to be some cooperation in some senses. I'm not saying it's not a problem, but I think there are some signs of progress in that context. I mean, obviously, other situations where we're not getting much progress, agreements about climate change and controls and so on. But nevertheless, I think that in terms of global databases, we are beginning to move. When it comes to individual databases for different places, what we've been very struck on in our group is that we've actually developed, I talked a bit about it at the Asia GIS, we've developed these city dashboards, basically, for different cities in the UK. I mean, they're things that can be knocked up in an afternoon, basically. I mean, it's just basically a kind of a screen which takes the data from the APIs that's being streamed continually, and it displays it within the dashboard. So we've got things like what's trending on Twitter, what the status of the Tube network is, so web cameras, the FTSE 100 index, the Dow Jones Industrial Average, things of that sort, all on these dashboards. Now, the interesting feature is that data is real-time stream data. Nobody's sat down and thought about whether it's comprehensive or not. What we found is that as we go from different city to different city in Britain, there's no real consistency. In other words, that some of the data exists. London is much better than any of the others, arguably, because it's a bit richer and it's got more attention and so on. Other cities are less so. And it's quite interesting in that context that we're very much base our research on the basis that that our data sets are consistent between different places. And, of course, for the census and things like that, they can well be consistent. But once we move to some of these other data sets in real-time sensing, I mean, when Charlie comes tomorrow, he's probably going to talk about how they're wiring downtown Chicago. Well, I'm not aware of anywhere in Britain where, a downtown is being wired in any sense. And so that's a different data set, which is only peculiar to Chicago. So I think that this question about data, again, it reveals the great variety of what cities are and how we approach it.
Hi, Chris Webster from Hong Kong U, Faculty of Architecture. Thank you very much, Mike. Inspiring as usual. A comment and a question. The comment is you probably agree that whether or not we get a singularity or a tip over into a logistic curve depends on movement into a new technological era. So it's all, in some ways, it's all about technology waves. You rightly said that productivity has been decreasing for 20 or 30 years. Real wages have been going down in the US and Europe for 20 years or so. The value of the dollar is now 10% of what it was at the beginning of last century. So there are some signs that the capacity to support people in high-density environments might be diminishing, which will tip the thing over. However, if there is a genuine new technology wave, wherever that may come from, we actually, in Hong Kong, we have a sort of we have an extreme example of how people can live. In Hong Kong, people live at whatever it is, 7,000 people per square kilometre. In Ap Loi Chau island off the south side of Hong Kong, it's something like 150,000 people per square kilometre. People can live at very high densities, but so if you map that out for the rest of the world, in some senses you get a limit. If you ask the question, what is the limit on human high-density living, inevitably I'd suggest you end up with questions about individual and public health. It seems that people are highly willing to live at very high densities and to do so voluntarily for the sake of earning income and increasing productivity and then getting a cut of that in terms of individual benefit via wages. That requires increasing productivity, increasing technology. So I think unless there is a genuine new technology conjugative wave, the logistical diminishment is inevitable through falling productivity, falling welfare, falling health, and falling happiness. That's the comment. Question relates to short and long-term planning. I wonder if we are moving into a period where we genuinely can do science on 24-hour city dynamics. We might find that we don't need so much long-term planning. And we could have a scenario where the last century, which was basically a century of experimentation in modernistic, technology-driven, long-term strategic planning of human settlements, we might find a situation where that proved to be a rather failed experiment. It's notoriously difficult in every single political economy jurisdiction to implement strategic long-term plans for cities. Shifting from that to a situation in which we can actually implement, and it's actually kind of the implementation which is driven by smart city technology that allows cities to steer themselves with very minimal strategic guidance. What do you think of that proposition?
I think you are absolutely correct in saying that some of the issues in cities are beginning to they've taken us by unawares in some sense. I mean, density is clearly critical, but also movement is to some extent. So, for example, in most cities that I'm aware of, on a casual basis, traffic congestion is still increasing quite massively. I mean, the notion that we're all going to sort of suddenly get out of our cars and, ride bikes or something is certainly not happening in Britain. I mean, the maximum number of cars bought last year of any time. So I think that some of these issues about, the quality of life in cities are very important. And I don't think we have a very clear handle on it. I don't think we have a clear dynamics on it in that sense, because you compare 30 years ago or 60 years ago with now, just almost impossible to make the comparison. Things are so different. And we don't have good data that has looked back historically. The other feature, I think, which is quite problematic in thinking about these questions, I probably hinted at it a bit, is that the things that we're actually focusing on, cities, are becoming more complex over time. There's no question that movement patterns in cities are much more complex. They're much more variegated and complex than they were 50 years ago. 50 years ago, the vast majority of people, travelling, for example, in cities were involved in the journey to work. I mean, that's now one of the smallest proportions of people actually travelling in cities. So what we're really saying is that cities are becoming more complex in that sense due to people having more choice in some senses. And that's a problem, because it means that everything is a shifting target. In other words, we're not very clear about how our urban science can actually grasp that issue about a system becoming more complex. Now, that's a rather philosophic issue, I think. I mean, because I don't think that is the case particularly in the physical sciences, or perhaps even in the natural sciences, maybe over long periods of time in the natural sciences, evolution and so on, that might be the case. But in terms of cities, things are getting much more complicated year by year. And that must change the nature of what we do. Now, that's not really an answer to your question. Getting back to the question, you're really saying there are lots of things that are there in cities that could well inform what's going to happen. I mean, it's not like the other question, really, previously. Inform what's going to happen, and we need to take those into account. And I agree with you entirely. I think the health thing is very important in that sense. And the smart city is giving us a better sense of what all that means. I mean, pollution data itself, I think, is very useful from that point of view, because basically pollution data can now be captured from multiple sources, basically, etc. I think there's a lot of work to do, basically. I mean, then there's the big question about how does that impact on human populations, and that's really the problem in some sense. We never have a definitive view that. I mean, I live in central London, and the pollution is pretty heavy, but it doesn't. If you look at the statistics, it appears that people like me live a lot longer than people who just live around the corner in a council estate, basically. And in other words, to tie the pollution levels to individual health characteristics is very problematic. I mean, you know this, to some extent. So, these are all big questions, I think, in that sense.
Two more questions. Three more.
Murat S., and I teach at the Urban Studies program at the Chinese University of Hong Kong, and I'm afraid I have even bigger questions. I think you're one of those rare people who are an expert on both urban science and urban informatics. And most of the time, there's a kind of big divide between the kind of things people study on different ends of the spectrum. And I think one of the important distinctions is the kinds of perspective we have. Now, as someone who studies urban science, I think in many ways I'm very skeptical of the smart in the smart cities, the rather progressivist, rationalist bias in it, and in some ways it's too optimistic. I have to remind myself, teaching urban studies all the time, okay, there are good examples. Try to remember the good examples, good things happening, right? So my question to you is, like, when we are going through this period in which there are actually a lot of non-smart and irrational things happening, right? Especially in the context of the economic crisis, Brexit, rising levels of fortressing that we see around the cities, xenophobia, crisis of representative democracy. The kinds of future imagination you have, I hope, is like closer to what we worry about. And there's so much dystopian thinking happening right now. How does that kind of modeling and imagination take into account, right, the ecological, political, societal crises that we see to be unfolding at the present, and their impact, their unpredictable impact, perhaps, into the future?
Okay, I think a couple of issues there. One is this question of the difference between urban science and smart cities or urban informatics. And in fact, the people in this area is quite a mixture at one level. There's a hell of a lot of people in urban science who really, are not involved in smart cities at all, basically. In some senses, I think of Yi here as being a little bit more like me, who's worked on urban science for a long time, but also has a lot of tools and techniques that are very relevant to the smart city. And it isn't easy to join these two. One of the things I think that is the joining is the fact that we're all involved in computers and digital. But having said that, of course, everybody in the world is involved with computers and the digital domain. So in some senses, this is a tricky one. I mean, what's interesting about this workshop, this conference, is that one is confronting for the first time urban science with urban informatics. And I think by the time one gets to the end of it, there'll be a lot of different perspectives, which will be interesting from the point of view of, asking this question, how do we pull them together? Do we pull them together? How do they, what is the synergy or lack of it between them and so on, and the kind of research questions. So that's the question about urban science. The issue I think you raise is very important, that what about everything else? I mean, I have this terrible problem in our group back in London. I nearly said Cardiff then. In London. Basically, we have quite a lot of physicists and mathematicians, and they don't really know anything at all about urban studies, right? And one of the big problems is that they're quite clever people, so they want to be interested in it, but there is this enormous domain of knowledge out there. It's like tip of the iceberg, really. And in some senses, embracing these other more qualitative, not unsystematic, but qualitative viewpoints, etc., is potentially very hard. I mean, I tend to reconcile all the competing views about cities by assuming that for any particular problem we'd look at, which had real coherence in terms of producing plans or whatever, we would assemble all of those viewpoints and somehow produce a dialogue in that context. Now, that may be wishful thinking, it may be optimistic, etc., but that's the way I think about reconciling all these many different views. But I do recognize that some of them are genuinely very difficult to reconcile with each other, etc., and that's something we have to work on, because we have to relate urban science and urban informatics to urban everything else, really, in that sense.
And God, this is a very interesting topic. And my question to you is, and in China we have already nowadays we say the super city, like Beijing, Shanghai, Shenzhen, Guangzhou. These four cities, the people almost 20 million to the 30 million people. And also Chinese government launched some months ago, China will have another 10 cities come into the super cities. The people are very happy Because you enlarge the city, the land parcel will be expensive, and the house also expensive. And my question is, from the urban science technology, can you say what is the limitation of the super city? Because in larger city, the problem, atmosphere problem, environment problem, the water supply, and also traffic, many problems. And what is your opinion from the theory? Can you give us the limitation? The largest city should be which population? That's my question.
I think this is a very interesting idea. This the super city that, in fact, on the Duncan Smith website, basically he introduced it by talking about different definitions of big cities. One of which is called the urban superorganism, I think, which somebody somewhere has coined, basically, but like Neil Brenner's planetary urbanization. So I think this idea of, which I didn't talk about at all, but is very relevant, how big is big, right, in that sense? Because at some point, then it relates a little bit to Chris's question too, but how big is big? And that's something that I think is much more problematic, etc. It obviously brings in a lot of qualitative issues about the markets and transportation and things of that sort, which have all sorts of negative externalities that really relate to cities and the growth of cities into big cities, etc. So I'm with you on this, definitely. I think the idea of a policy for really big cities is, I'm not very clear what my view about it is. I'd have to see what the rationales were, etc. Because I think that if we say that, right, there's a policy to make cities bigger, we have to unpack it and see what it means, etc. in this context. If you said that in the UK, for example, most people would say, well, what does it mean, right? We've already got a big city. It's called, England and Wales, basically, or perhaps Scotland, So in some senses, and the Netherlands is one big city. So I think this is a very interesting, it's a very interesting issue, this question of how big is big. Yeah.
Hello, Mike. I believe I have the last question, yes? Yes, I will play a bit of devil advocate here. And every time I told my mom that I belong to the Institute of Future Cities, she told me that I'm a fortune teller. So I believe that you are part of the gang as well. So when you show the data, you show the statistical trend and all these analyzed, that demonstrate how the data move across time in a more transformational kind of way of doing things, so that you can curve fit it and things like that. That seems to be okay if the society and everything else is relatively stable, which is the case in the last 50 years. Okay, but when you come to a disruptive force, for example, who can imagine China is today 50 years ago? Nobody. Right. And the disruptive force was one man telling me or telling everybody that black cat, white cat, and catch mouse, good cat, okay? And everything go crazy, okay? And things like that. So I just wonder whether or not urban science and informatics can cope with this kind of disruptive forces in their modeling, in their scenario planning, things like that, that will allow this kind of funny things to be accounted for when we predict the future. Or it cannot simply do that?
I think that this question of disruptive force is particularly important because, in some senses, I guess the disruptive force, it may not be regarded as disruptive. I was really alluding to is the notion that this explosive growth will end, basically, etc. But of course, we don't know what will happen after it. It may not just be a kind of smooth, uninterrupted. It could well be as disruptive as anything we've seen, etc. And that brings the notion about what is a disruptive force, what is a technological disruption, and they seem to exist on many different scales. That's the first thing. So, for example, if you think of let's say Airbnb or Uber or something as a disruptive force. Well, it pales in insignificance to some of the bigger disruptive forces like Brexit or whatever. So in some senses, there's a whole scale, spatial, sectoral, temporal scale of these forces, basically, which are not going to go away. They're there anyway, and we don't have a sense of whether they'll get more significant, etc. There'll be new ones and so on. So I'm very much with you that I think this sort of scenario I was painting can very much be consistent with all sorts of forces within it in this context. It still doesn't get away from the fact that this world population growth is ending, and it doesn't get away from the fact that everybody is urbanized in this particular context. And also that we need to define what our cities are much more closely. So I'm with you on this in some senses. Chris's point, I think, about how disruptive is the technological change, the wave of change, that's a tricky one too, because, I mean, clearly computation itself has been a massive disruptive force, almost impossible to talk about as a disruptive force. It's so central to, the way we do things, basically, now. So there are some interesting issues in that sense. I sort of said at the end of the talk that what would be very nice to do in a talk like this is to actually present you with a picture of all of the kind of dynamics that might actually occur over the next 100 years. And I didn't attempt to do that. No one's really done that. I mean, there's from many different perspectives, many different cycles, really, in that sense, all of which have different degrees of disruption. And the degree of disruption also lies in the eye of the beholder to some extent, in that sense. So I think all of these things have to be put onto the table in that sense. I hope in later in the meeting we'll talk about some of these disruptions by people who know a bit more about it than, say, me, for example. Yeah.
Okay, thank you, Mike.